I don't even know how to record.
It's not like I was talking about.
Jason, what'd you say? Can you repeat it for us?
What the crap? Only not crap.
Well, it's like the equivalent of what the crap.
All right. I have candy today, so if you answer questions that I ask, you can get candy. It's already getting light compared to what it was before, so. I do. It's a wide variety of candy as well. So. I've got gummy eyeballs. I got peanut butter M&Ms. I got suckers. I got Snickers. I got Junior Mints. Jolly Ranchers. Blow Pops. Can't have that. You know what I'm talking about.
What if I'm leaving?
Whoppers. Who likes Whoppers? I find them disgusting. We made a pile of when they first got their candy. We made a pile of all the candy they didn't want. Milk duds, Whoppers, those weird orange and black candy. It just gets stuck in my teeth. You know, like the orange and black, like the wrapper's orange or black, and then the inside's I don't know what. You know what I'm talking about?
No.
I have the answer.
It's like taffy-ish question. Taffy, what, taffy stuff?
Yeah, taffy stuff.
No, you know you can't eat. Oh, dumb, but kind of supposed to look it up. Okay, so this is our last unit for this class, and then we have final exam. This unit is probably maybe the most difficult because it is exponential function, it has logarithmic functions, and it has polynomials of higher degree. So this week and next week, we're going to do exponential and log stuff. It would be perfect if we could get a test in before Thanksgiving break, but it's not going to happen. So I think there's 2 quizzes in this chapter, and then there's 2 quizzes for review. But we really are getting close to the end, children, right? So have you counted down the days? 2 full weeks, Thanksgiving break. After Thanksgiving break, 3 weeks, and then it's Christmas break.
We have 2 full weeks of Thanksgiving.
No, 2 full weeks until Thanksgiving break.
That'd be awesome.
Right? This week, next week, and then we only have 2 days. So.
For basketball, we have one day off.
Because you guys are going to state.
What are you trying out?
You're gonna have a winning record this year.
Okay. What makes a function an exponential function? An x of an exponent, right? So that's kind of the big thing. Maybe you remember doing this in a previous math class, maybe not. We say every x in the, what does this weird R mean? Real number, so that means the domain is all real numbers if a is greater than 0 and a is not equal to 1. Because you can't have 1, right? 1 to the x is always 1. That's not exciting. But if I have like 4 to the x, what happens is I keep picking bigger and bigger values for x. It keeps going up. Oh, whichever wins.
Dang, I didn't know the question.
You're already trading candy?
You can like calculus trade candy.
No, it's ridiculous.
Keep it. Keep it.
It's 6 or 7.
6 lives. Those are gross. Okay, so we're going to graph these. And I know your graphs aren't the greatest. Sorry, graph yourselves. And it's really small because I want to squish them all on one page, which makes it more difficult, right? So I'm going to make a little XY chart for each of these. And I'm going to pick like 1, 2, 3, 0, -1. I won't pick that many next time, but I'm not going to let you tell me what 2 the first are and get candy. Because if I plug 1 in there, I just get 2, yes? If I put 2 in there, 2 squared is 4.
8.
3 is 8. What happens when I put 0 in there? 1. Now I stuck it first. So these people raise your hand. You just gotta say it. You just gotta say it.
Oh,
Keep are also not my favorite. This kind of my favorite. Those are good. Caramel apple pops.
Those get stuck in here. Who talked about the water?
Oh. Well, someone's car alarm's going off.
hey, can I just say 1/2 and then some?
Um,
Give me that confidence.
It is 1/2 because a negative exponent, right? 2 to the -1 means you move it to the bottom. It's kind of oozing out the bottom. It's got to eat it at your own risk. we graph this, at 1, I get 2. At 2, I get 4. At 3, it goes up to 8. At 0, it's at 1. And I know it's really hard to graph. At -1, it's at 1/2. And think about as we plug in more and more negative numbers. If I plug in -5, I would get 1/32. If I plug in -6, I get 1/64. Is this graph ever, no matter what I plug in for x, am I ever going to get 0 out of it? No, which means that this side goes up like this, and what happens over here? It's an asymptote where it gets closer and closer to 0 without ever going there. Ooh, Reese's Keys? Whoa. Still, you're not getting candy if you hit every single candy. Even if you get one right, I'll just eat your candy instead. I'll be like, this is for you, and then I'll eat it. So the domain on this is all real numbers, because you can plug in whatever you want in for x, but the range is not all real numbers. Son of a biscuit, why did you do that?
That's a substitute for that.
The range is 0 to infinity because you will never get 0 out of that, right? It'll just keep getting closer and closer, and it goes up forever. 6 foot, do you like 6 foot? What happens if the exponent's negative now? What's going to happen? It's going to be backwards, right? Think about our transformations, or think about what's going to happen now when we pick our numbers in. Everything's going to flip. To me, chocolate candy is the only good candy. Like suckers, sweet tarts, Starburst. Parker, when I said pick out 20 things, he's like, I need all the Skittles, and he took all the Skittles first. That's my children. This is why I had to get this out of my house, because they'll eat all the sweet tarts, Skittles stuff, and then they'll leave me all the chocolate, and then I just eat it all. I said I'd give it all to you. If I plug -1 in here now, that actually becomes 2 to the first, because negative of a negative. So the negative side is actually going to go up. Why does it do that?
So you didn't update it this morning.
I know, but I did. I eventually did, and it worked. But she's in my first start class. And now when I plug 1 in there, that's going to give me 2 to the -1, which is 1/2. So if you remember our rules for transformations, a negative inside the function is a reflection over the y-axis. We're going to take the same graph here, and we're just going to flip it over. So now this side's going to go up, and this side's going to go down. Domain range still the same? That was my question. This graph is called exponential growth because as x gets bigger, y is growing very quickly. We can talk about bacteria growing exponentially. We can talk about population growing exponentially. And then this side, as x is getting bigger, y is actually getting smaller, getting closer and closer to 0, but never actually getting there. What's that one called? Decay. It's decaying over time. We can also talk about population decaying or decreasing. We can talk about half-life stuff from chemistry. And then we can just do transformation. So I just did the 2dx plus 3. What's the transformation mean when we add a number on the outside? Look at all those people saying up 3. Which means we can take this same graph and we can just move it up 3. A little stuff to share. In my geometry class, I gave them all Black and Cappy while I was teaching, and then they all had to open it and read the joke while I'm teaching. They didn't do it so well. Oh my gosh, I thought I was doing it.
Yes. What happened to the wind? It blew away.
asymptote in me.
I don't even understand. All right, so when I plug 0 in there, I still get 2 to the 0 is 1, but now I add 3, so it goes up to 4. When I plug 1 in there, I get 2 plus 3, which is 5. So this side's just going up. When I plug negative 1 in, I get 1/2 plus 3, which is 3 1/2. Is my asymptote still going to be in the same spot if I move everything up 3? My asymptote's also moved up 3. So that's the big thing I want you to be aware of, is when you are graphing these, if you made your asymptote go all the way down to 0, then you're going to get marked off on that. Because our range now has changed from 0 to infinity to 3 to infinity. There's some orange here.
That was so weird, right?
Because I'm afraid if I throw like this, I'm going to hit someone in the face. So I try to throw it up in the air a lot, so you have time to get underneath it. Or if I overthrow it, it's not going to hit someone in the face. I throw calculators a lot, and one time I threw it not underhanded, and it almost hit someone in the face. So I just toss things like this now. I learned my lesson. So we could say generically, if we have y equals a to the x, where a is greater than 1, right? So if your base is bigger than 1, do you think that's going to be exponential growth or exponential decay? Growth. So that's like 2 to the x. So we can say it generically looks like this. It's exponential growth. As x gets bigger, y gets bigger. The y-intercept at 0. And if, again, now this kind of all depends on what the exponent is, but if it's just a to the x, where x is positive, if your base is between 0 and 1, so a fraction like 1/2 or 1/3, that's going to be getting smaller over time. So that's going to be our exponential decay. And that's going to look like this, roughly speaking. I hate my smartboard. Good to go so far? We're done 2 days today. We're totally going to get done with this too fast. So you have 2 things you have to do in your homework today. One of them is some graphing. It's your favorite. The other one is solving some exponential equation just by making them the same base. All right, so it's kind of fun. We did this in pre-calc today too. So if 2 exponential expressions have the same base or equal, then their exponents are equal. So we could say if a to the x equals a to the y, if they have the same base, then we know that x has to equal y. Do you agree with that statement? If their bases are the same, the exponents have to be equal. So the majority of your homework today is doing stuff like this, where it says solve each equation, and you should be able to write them as the same base. So when it says 3 to the x plus 1, look at 81 and say, could I write 81 as 3 to a power? Dylan says 3 to the 4th power. Is that true? So 3 to the 4th power, and you might have to, punch the numbers on your calculator. And why would I want to do that? Because now, if I know this, can I just set these exponents equal to each other now? So now it's a really easy equation. I can just say x plus 1 equals 4. Subtract 1. X equals 3. And I know that one wasn't so bad, right? You probably could have just figured that out there. But that's the process. Look at number 2. Can you write 8 as a power of 4? But could you write 4 and 8 both as the same base? 2. You could do that. We're not there yet, but yes, you could. If you remember. But we could write this as 2 squared, and then we'd still have that 2x minus 1 there. And 8 is the same as 2 to the third, and then we'd still have that x plus 3. But yes, you're right, Chloe. You would still, your answer would look uglier, but yes. So now if they're both base 2, can I just set this equals this? And now it's just some good old algebra. You can distribute if you want. And now you just have to solve that for x. So this is what I was going to teach on Friday, and then they all convinced me that I would just have to reteach it to all that were on. And then Chase said the bad word.
So 8 out of them found out about first century scholars then.
They did. So I find out that. We found out how old you have to be a bartender. We looked that up. I Googled it. 21. You can serve when you're 19, but you can't be a bartender until you're 21. I got 11. Did you get 11?
Yes.
Okay. What's about the last one? What looks different on it? There's an exponent and an exponent, definitely. So step 1, can you write it as the same base? Can you write 27 as 3 to the power?
Yes.
3 to the 3 to the third. But now our exponent has x squared in it, which means our good buddy quadratic has come back to visit us. I hope we're feeling pretty good about quadratic equations at this point in our lives. Factoring, complete with square, quadratic formula. So if the bases are the same, I can just say x squared minus 7. My goodness. Out of control. X squared minus 7 equals 6x, because 3 times 2x, 6x. So I could say x squared minus 6x minus 7 equals 0. And I don't care whether you complete the square, you do the quadratic formula, or you factor if it's factorable to solve that problem. But that's what we're going to do. Is it factorable? Is there anything that multiplies to give me 7 that subtracts to give me 6? Oh. 7 times 1 is 7. Negative 7, positive 1. So x equals 7, x equals negative 1. Do both of those work in that problem? Yeah, yeah. Because if you plug in negative 1 here, you get negative 6, and you also get negative 6 there. Exponential, they should all work. When we get into logarithms have very restricted domains, so they're not going to all work. But exponential functions, domains all real numbers. So unless there's something crazy going on, they should work in those problems. So your homework is not that much, because I was planning for it to be Friday homework. But 1 through 8, all, I believe those are the solving the equations, and then 15, 16, and 18, if I remember correctly, are graphing ones. Tomorrow we're going to do applications of this, which means tomorrow we're going to talk about half-life stuff, like from chemistry stuff, find how long it takes for this to decay to this amount. We're going to talk about compound interest and finance, and if I took a loan out at this interest rate. That sounds exciting, right? So that's the plan for tomorrow, and then 5.3 is logarithms, and then 5.4 is more stuff with logarithms, I think. So we won't have a quiz until next week, though, so that will, there's a lot of stuff on that first quiz. So you have